Hello friends, welcome to Power Electronics. Today we will discuss the single phase half wave circuit with RL load and freewheeling diode. In previous class we have discussed the circuit with the RL and R load. Today we will discuss the RL load with the freewheeling diode. The waveform of the load current, that is I naught, can be improved by connecting a freewheeling diode. A freewheeling diode is also called as bypass or commutating diode. This diode is used to improve the waveform. In the previous classes, what waveform we have received, that some part went to the negative, that is the voltage becomes zero, but here the current is not zero. So to improve the output waveform, we will have used that freewheeling diode. So if you look at the diagram, the same here, only the change is the freewheeling diode. So we will discuss it in detail. At omega naught equal to 0, the source voltage is positive. So here the supply current starts from here, flowing through the thyristor, then it reaches here to the resistor, then inductor, then flows to the back path. In the here, the freewheeling diode is not working because it is reverse bias, because this is positive and this end is negative. So freewheeling diode do not conduct in the positive cycle. At omega naught pi, the source voltage is equal to 0. As you can see, the source voltage here is 0 at instant pi. Source voltage Vs is 0 and just after the instant as Vs tends to reverse. So freewheeling diode came into the picture. All the load is transferred to freewheeling diode. So as you can see here, this is the Vs, here is the sinusoidal waveform. So here V naught is the output voltage. After and delay of angle alpha, the thyristor starts conducting. We have triggered it here. So as you can see, the source voltage is rise gradually and then it falls and reaches 0 at the instant of pi. If you look at the load current here, load current starts from here, it rises and reach a point here. The load current here is not 0. Voltage here is V naught is equal to 0, but I naught, that is load current, is not 0. At that particular instant of time, this inductor is charged with a polarity of plus minus, and due to the negative half cycle, here it is plus, here it is minus, here it is plus. This negative appears across this thyristor. So this thyristor gets turned off. And this freewheeling diode come into the picture, and this inductor, when this supply is removed, it changes polarity from plus minus to here it is minus, here it is plus. So it discharged to the inductor, sorry, it discharged to the freewheeling diode. You can see the cycle, the second cycle, which was not conducting in the RL load as well as R load, it starts dropping here. At the instant of next triggering, at the instant of next triggering with the angle delay of alpha, then again the thyristor starts same conduction. Then again the process repeats, the thyristor starts conduction. As you can see, in previous class we have seen that the load current was 0 and it was not conducting in the reverse mode. In the reverse cycle it is not conducting because thyristor, it is negative and positive, that means thyristor is not working. But here in the case, what you can see that at the instant where the thyristor stops conduction, all the load is shifted to the freewheeling diode. So you can see here it rises, then it drops, then it rises. So if you look at the thyristor current, first the thyristor current was gradually increased here, then it suddenly falls to 0. Why? Because the reverse voltage is across it, so it is 0. It do not conduct in the negative half cycle because all thyristor was commutated and this space is left as 0. This current is absolute 0. Same it repeats again, this cycle again it repeats same. If you look at the current through the freewheeling diode, what we have observed here, that freewheeling diode was not in the picture at the start because it was reverse biased. Here it is positive and here it is negative. The diode was reverse biased, so it is 0. But as the load current, as the inductor discharges through this freewheeling diode, you can observe there it rises and then it falls and reaches the point 0. Again you can see the time period here, again it rises and then it falls to 0. If you look at the voltage across the thyristor, this is the delay angle alpha. The thyristor was conducting in the forward cycle, so it is short here. After that, the thyristor gets commutated and the current flows through the freewheeling diode. So you can see here, if you minus it, the load voltage with the source voltage, then you get this value here. Same it repeats again and again. So this is the explanation of this single phase half wave circuit with RL load. Why we have done this and what improvements we have got. By the use of the freewheeling diode, first thing, what advantages we observe, that input power factor is improved. Here input power factor is improved. Second thing what we observe, that load current waveform is improved. Third point what we got, as a result of this, load performance is better. Load performance is better. Also we have observed that as energy stored in the inductor is transferred to the R during the freewheeling diode period, overall it converts efficiency improves. So these are the advantages by using a freewheeling diode. In the RL as well as R load, we haven't used any kind of freewheeling diode. So freewheeling diode have saved, also it has improved our efficiency. Thank you very much.